Okay, so let's get into it. I want to start with some basic discussion of Excel. Um, well, I guess I'll set the stage here. I got a bunch of numbers flying around here. Let me kind of explain the problem I was working on. Uh, I got a scratch ticket for my wife for present, and I was thinking about math and thinking about this introductory course and applications of math. And I thought, oh, the probability, the odds of winning, how much you could win, all of that is tied into lottery tickets. And lottery tickets are rich with, applications of mathematics. So this is what I found online. I thought that it was on the actual ticket, but then I had to go do some research and find the actual odds. There's a bunch of different prizes for this particular game, starting from $5 up to 75,000. 75,000 is the one on the front because that's the most enticing prize that you're going to win. That's the least common prize. There's 10 of them, compared to over a million, $5 and $10 prizes. One thing that's interesting here is that and I kind of struggled with understanding what was being presented to me. It does not tell me how many tickets were produced. That would be helpful, but I can kind of infer that from the odds. Now, first of all, odds is not the same as probability, and we're going to talk more about probability later. But basically, I needed to take this information. Unfortunately, it was in a picture. This is a picture, not a table. So it's not easy for me to do that. So I had to type it by hand. So that's the first part here. Let me put some labels on my little table here. This is the prize value. These are the odds. So because I hadn't thought about odds in a while, I had to go and look up a formula for converting odds into a probability. And this is as a decimal. So I could convert that into a percentage if I wanted to. There's an easy way to do that with Excel. And then I did some math here. But before we get into the math here, let me just talk a little bit about Excel. Excel is going to be a very important tool for this class, and it's setting you up for what you need in 102. It's a calculator. It's an organizational tool. I do my budgeting in Excel. It's just a useful organizational tool, and we're letting the computer do the computation for us. So we don't have to sit down with a pen and paper and like figure out what, I don't know, 0.00250482 times 30 is. That's not necessary because the calculator can do it for us. And in this case, the calculator is the computer is Excel. So some basics about Excel, some vocabulary. You've got rows and columns. The columns have letter names. The rows have number identifiers. And if you put them together, like F6, that denotes a cell. Okay, so I'm going to go ahead and put my block in F6. I'm going to go ahead and fill it in with a color. This is F6. Excel doesn't care whether you say uppercase or lowercase f. It's the same thing. So this is F6. So when I'm doing stuff in a spreadsheet, I can refer to columns, rows, or cells, depending on how specific I want to be. And one of the things that we're going to get used to is starting with just do some basic computations. So we should be able to add, subtract, multiply, divide using Excel. And then we're going to do that using cell references. And that's, we'll kind of circle back to this table and what I discovered here about this game. So the first thing is that if you want Excel to behave like a calculator, you go into a cell. I'm in D8 right now, and I would start with the equal sign, and then I do whatever I want to do. So 2 plus 6, you know the answer to that. It does the calculation for me. When I click into here, it still shows me how it was accomplished, right? And this is important because from the standpoint of like showing your work, how did you come up with the answer? Which is relevant for the work that you do, because to me, the answer is not as important as the process. We're going to circle back around that every week and every time we're talking about math. Let me just start by saying the reason that's true is because how we come to understand what the answer is really important and valuable. And in some cases, it's sort of, you know, becomes trivial because we just expect things to work properly. But, you know, ultimately that has to do with trust rather than the fact that the process is unimportant, right? So for instance, when I go to the grocery store and I scan a bunch of things at the self-scan and it gives me a total, I don't question that it has been done right. But that is a question of trust, not the fact that ultimately the only thing that matters is the answer. The process is important. And it's actually, when we talk about things like checking out the grocery store, there's a lot of like sub steps and little things that are happening on the way. So it's not as simple as just adding up a list of numbers. But I'm really grateful that the scanner does it for me because I don't want to have to do it myself. And if I was doing it myself, I might have less trust in the outcome than having a computer do it for me. Anyways, let's put that to the side. There's addition. Here's subtraction. Of course, the order in subtraction matters. So saying 7 minus 2 is not the same as saying 2 minus 7. Here's division. I use the forward slash. 3 divided by 4 is 0.75. And of course, in division, the order matters too. 4 divided by 3 is not the same thing. Just write that down real quick. Order matters in subtraction and division. And then in multiplication, we use the shift 8. That's the asterisk symbol to be multiplied. We don't use the X symbol in Excel. So those are the symbols. Some of them are familiar to you, the plus symbol, the minus symbol, the division. You probably are familiar with that. It looks like a fraction bar. And the multiplication kind of looks like a dot. Might be the first time you've used that in this, if you are doing multiplication for the first time on a computer. Okay, so those are some basic things that we need to be able to do. Let's go ahead and jump into actually talking about percentages. So, and this starts our actual content for module 1. I would just start with some meaning here because, and a reflection on the fact that you have learned percentages before. Well, you've been taught percentages before. Whether you learn them or not is another question. But my guess is that you learned them and then you forgot, and you know, you just got to sort of dust off the rust here. But basically, let's start with breaking the word apart. Percent is literally divided by 100. And that's important because if I take something like 23 and then this symbol percent, which by the way has the elements of divided by 100, look at that. There's the division bar and there's the 0, 0, this, which is, you know, the number of zeros you need to make 100. So this symbol is intended to remind you that it literally means 23 divided by 100. So these two things are equivalent. 23% is the same as 0.23. Now, you're not going to run into many situations in the world where you're required to, you know, convert a percentage into a decimal on the spot, or ever, really. I mean, the point of percentages is that they get used a lot in a lot of different contexts. I would start with tax being the first one that you probably are running into all over the place. I've got some receipts that I wanted to kind of share with you, and I'll probably take a picture so you can see. Put it in front of my face, but still make it hard to see. This was some grocery shopping I did at Cermak. It says tax code 2.25% tax, which is interesting because my first day at National Louis, I went down to Jollibee and got myself some fried chicken, which was delicious. And it says there that I'm paying some tax, but it doesn't tell me what the tax rate is. I paid $1.50 tax on 1398. Well, actually, this is not my receipt. This was sitting on somebody else's. But anyways, somebody paid 1398 for their meal and then paid 150 on top. So they actually paid 1548. And being a math oriented person, I can tell right away that's not 2.25%. So anyhow, let's get to kind of the most common way that percentages show up in our lives, which is we want to find a specific percent of something. And we'll just, apply it to money because that's the most common, type of thing that you would see. But if I'm into sports, this could come up a lot in terms of, the percent completions or something like that. So let's just take this 2.25% number since I just read it off this receipt. And I think the taxable amount was 2267. So when I added things up at the scanner, it was 2267. And then at the end of the process, I'm having to pay tax to the city of Chicago. Well, I'm paying it to Cermak, and Cermak is paying it to the city of Chicago or somebody. And so this computation is important. And of course, this is an example of where you don't actually have to do any math because it's being done for you. But how would it be done? One of my hypotheses about percentages, I have a daughter who's 17, and so if I can squeeze a math question here and there, I'll gladly do it. But the thing that I discovered over the years, once she learned percentages, is that she would come back in a percentage situation would arise. And of course, I want her to figure out what percent of, what's 10% of 30 or something. And then she would say, do I multiply or divide? And I think that reflects something important about the way people think about mathematics, that there's a way to do this problem. Right? There's some computation that needs to be done. I know it's 2.25 is percent, but I got to change it to a decimal and then multiply or divide. I don't remember which one. And the thing that I always like to remind her is that you don't have to remember that. You can sort of reverse engineer that fact. And I always like to go back to something like this. 50% of something is half of it. And that's a half of it is fairly easy for people to compute because you just got to cut it in half. You got to cut it into two equal parts. So if I say 50% of 80, I imagine that you can tell me the answer to that question without really doing any mathematics, without going to Excel or getting your cell phone out and plugging in the numbers. And so what I would recommend, if you forget, is that you just try it out. Like how would you do this problem mathematically? So first of all, I've got two numbers involved, 0.5, not 50, because 0.5 is 50 divided by 100. And the question is, am I multiplying it by 80 or am I dividing it by 80? Of course, if it's division, right, the order matters. So it could be a bunch of different things. Now, this might seem annoying, like, why don't you just tell me whether to multiply or divide Aschenbrenner? But from my perspective, it's the old, teach a person to fish paradigm. Like, I could tell you whether it's multiply or divide, but are you going to remember that in, 2 days? Or are you going to be back to being confused about whether it's multiplying or dividing? So that's why I want to give you something to hook onto. So you can always go back to, well, wait a minute. I get confused, but 50% of 80, oh, this is the right approach. If I take 0.5 times 80, that gives me 40. I know that's half or 50% of 80. So this is the right way to do it. And therefore, the general approach with finding a percentage is just to turn the percentage into a decimal and multiply. And the second thing that, just kind of going back to the story about my daughter always being confused about multiplying and dividing, is the reason that math is annoying to some people is that they feel like it's just a bunch of rules and things that they have to remember, steps. I always like to think of dance steps because My daughter likes to do TikToks, and she's like, okay, so you're going to start with this step and do this step, and then you do that step. And it's like, oh man, I can't remember all that. Well, that's how people feel about mathematics. But the point is, you don't have to feel that way about mathematics. If you do something regularly enough, you will remember how to do it. And if you do it so much, you will remember it for the rest of your life. Like my telephone number from being a kid, I still remember. But if you just do it in math class a couple of times and then you don't do it for a while, and then you go off and do something else, and it's like, well, you're not going to remember that. So that's just the way your brain works. So you figure out, is this something that I really want to know? Or should I come up with some kind of approach so that I don't have to worry about whether I remember it or not? All right. So for instance, here, now let me show you something cool about Excel. So we could do this in 2 steps, right? If I said there was a problem on the worksheet that said, give me 2.25% of $22.67. You could start with 2.25 divided by 100. And then you could say, okay, now I want to take that number and I want to multiply it by 2267. Now, notice that this number here, the answer to the second math computation, is not the way we would talk about money. So this also brings up an important point about rounding, because they're not, you can't charge me this. I mean, if this is money, the thing on the left of the decimal is dollars, the thing on the right of the decimal is the cents, but it only goes out to 2 places. And I'm not going to be paying attention to this stuff out here. So in reality, the answer would be 0.51 because of rounding, because 51 cents is the amount of tax that's going to be added. So so if the answer was, or the question was actually not figuring out the tax, but how much am I going to have to pay at the store, then the answer turns out to be 2267 plus 0.51. Notice that the way I've done all of this math is that I've left a trail of evidence of how I did it. What is the work that I did? Even this step where I decided to take this number and round it to this number, I made a little note that I was rounding. And then this is my final answer. And I could do some color coding because I like color coding. Sorry, I didn't really ask the question properly. Something like Ben goes to Cermak and buys groceries that are 2267 in total, but then has to pay 2.25% sales tax on top of that. How much does he pay, including the tax? Okay, so this is an example of, here, let me just do that. Just do this, merge and center, and wrap text. Okay, so this is an example of a real question, doing the math, kind of setting up the problem, doing the math, leaving a trail in Excel, providing the answer at the end. If you're going to do your work in Excel, which you should, you can just submit an Excel book to me as your submission. And then I can look through it, I can see what you did, and I can give you credit for that. If you just tell me, you show me nothing here, and you give me the 2318, I'm going to be wondering, I'm going to be happy that you got the right answer, but I'm going to be wondering, where did it come from? So keep in mind that for full points, you want to show everything that you've done. Okay, so that addresses the first type of percent question, which is, I just need to find a percentage of something. Now let's move on to looking at, finding a percentage. So this is another common type of situation that arises. It doesn't arise for everybody on a daily basis, because it's a certain type of thinking to want to quantify a ratio as a percentage. But there's plenty of examples, and as I go around the world, I can think about, lots of situations where finding a percentage would be relevant. I'm thinking a lot about football right now, for football playoffs. So for instance, if a player completes 32 passes and they attempt 43 passes, what is their percentage completion? So percentage completion is a statistic that people talk about in terms of quarterbacks. Basically, what I'm doing here is I'm going to convert the ratio into a fraction and then a decimal, and then I can make it a percentage. So you just start with the division, 32 over 43, and then I'm going to turn this into a percentage, and I can do that one of two ways. First of all, if I do 0.744 and I just hit this little percent button, it'll actually turn into a percent for me. And if I hit this button, it'll give me more decimal places. So this is the answer. Mathematically, I'm doing the inverse operation of dividing by 100 because I'm going from percent to decimal. Just make a little table here just to kind of illustrate the logic of what's happening. So to go from a percent to a decimal, I would divide by 100. And to go from, it doesn't like that, does it? And then to go the other direction, go from a decimal to percent, logically, I would do the opposite, which is to multiply by 100. So that's sort of the mathematical way I could get there. I could take the 0.744186 and I can just multiply by 100. And this is the percentage with a lot more decimals. And typically, when we're talking about quarterback percentages, we would round that to the 10th of a percent, or probably a whole percent. 74% completion, 74.4%, which is actually really good. Like in a season, good quarterbacks are throwing like 65 to 70% completion rate. Okay. Now, it's not like one thing I kind of skipped over here is how did I decide it was going to be 32 divided by 43? Because I said earlier that in division order matters. So how do you know which way it goes? Well, that's not as easy a question as it sounds, because although a simple rule of thumb would be always put the smaller number on top of the larger number, that's not exactly right, because there are situations where I could be looking at the percent change and then the top number actually could be larger than the bottom number. So in terms of the ratio, this is passes completed over passes attempted. And the key here in thinking about the meaning of this ratio is that the top is a part of the bottom. It's what we call a part to whole ratio. And so often when we're making a percentage, that's the situation that we're looking at. There is a part, which will be the top, and then there's a whole, and that will be the bottom. But let's go ahead and move into this more complicated situation, because often we're interested in how things change. So let's say, I went from earning $13 an hour to $15 an hour. Okay, so how did my earnings change? Well, there's a couple ways I could quantify this. I could just say I got an raise of $2 per hour. That's an accurate statement. I went from 13 to 15, just subtract, you find the differences too. So we can also express as an increase. My rate of earnings, which is my pay rate, increased by X percent. And this is a situation where, again, we're going to sort of make a ratio and turn it into a decimal, turn it into a percent. So how do I figure it out? Well, first of all, the increase was $2 over the sort of base or the starting number. So the starting number was 13. I started at 13. It increased by 2. The ratio I'm interested in is 2 divided by 13. And again, I'm going to change this into a percentage. So I'm going to say 15.3 or 4%. So my final answer would be my rate of earnings increased by 15.4%, which is a pretty decent increase. One of the percentages that you might have heard being thrown around a lot over the last couple of years is inflation numbers, which are expressed as percentages, and these are increases in prices. And the reason why it's been such a big topic of conversation, I mean, for 20 years, it hasn't been talking about inflation. People are like, what are you talking about? Even though inflation has been a thing for, a long time, 100 years. I don't press me on that, the sort of economist perspective of why inflation happens. But the point is that in the last 2 years, inflation got really big in a way that we hadn't seen in the US in, I think, since the 80s, 70s, 80s. So that was a big deal. You noticed, if you were buying things, you noticed that prices went up and you were like, oh my God, these eggs used to cost this much and now they cost this much. It was a very visible change. So that's also potentially connected to wages and how much people earn. So having this expressed as a percentage allows us to compare more easily. Like if my earnings went up 15.4% and the price of other things went up 6%, then I'm kind of doing better than I was. But if the prices went up 9% and my earnings went up 2%, then I'm not really keeping up with things. So that's why percentages are useful in that context. All right, let me pause here and kind of ponder how much more I want to say to you. Okay. I want to do one more question. I think that given this question, you should have enough to kind of attack everything in the percent worksheet. First of all, a little bit about authentic questions. I want, in general, especially in class, I want to spend time on authentic questions. To me, authentic questions have a few traits. Number one, you can imagine that they're real questions, not made up questions for the sake of doing some mathematical computation. And number two, they're going to be real in the sense that not everything is necessarily provided straightforward in terms of all the information you need. You need to kind of check in with your experience in life to think about whether there's other information that's important or whether some information that was provided is irrelevant. For instance, if I put in, I went at 2 p.m. on Friday, this information is probably irrelevant to solving the problem, but maybe the coupon has some, expiration date, and then actually what day I went could make a difference. Okay, so let's dig into this problem and think about it. I have a coupon that gives me a 10% discount to find some shoes I like for $79.99. So stupid. Why not? Let's just call it $80. How much am I going to pay at checkout if I have 420s? Is that going to be enough? Okay, well, 420s is how much money? That's $80, right? Because 4 times 20 is 80. So actually, I'm pretty close to what I can afford. The discount gives me a little bit of spending room. I wonder if you can think about the situation and bring in, there's another important piece of information that I have not provided directly because I'm trying to do authentic questioning here. All right. I hope you said to yourself, this person is going to be paying sales tax if they're in Chicago, because we live in Chicago and we pay sales tax. Sales tax is not a thing everywhere, but it is a thing here. Let's just look it up because I didn't give you that information directly. So say sales tax in Chicago. And that reminds me that I need to go back to that thing at the beginning. Okay, 10.25% in Chicago, Illinois. All right. So I need to think about, I need to apply this discount and I need to pay the tax because the store's not going to give them to me tax free because the store has to pay the taxes on shoes. So yeah, those two things have to be taken into consideration. I'm going to do one of them kind of the way that I presented earlier, but then I'm going to do the other one in this more direct way, which is what I would call the multiplier approach. Just a reminder that there's always more than one way to do a problem. So don't get into your head that there is a specific way to do a specific type of problem. There's always multiple ways to solve problems in mathematics. That's one of the beautiful things about problem solving and math. All right, 10% discount. So I could be asking the question, what is 10% of $79.99? Because that would tell me how much the discount is, and I can take it off the price of the shoes. So I know that I need to take this, turn it into a decimal, 0.10, and then I multiply by 79.99, and I get 7.99. This, if I'm going to round it, I'm going to say I get a discount of $8. We haven't talked much about rounding, and I should probably make a whole other video on that because it's one of those sort of underlying skills that's important, but also some students still are bringing confusion in from previous mathematical experiences. So if $8 is my discount, then my total $79.99 minus $8, $71.99. Okay, so this is how much I'm paying, not including the tax. So now I need to get the tax involved. And let me show you the multiplier approach. So in general, if I need to increase or decrease the price of something, I'll start with 100%, add or subtract, depending on whether I'm doing an increase or decrease, the percentage. So in my case, I'm starting with 100%. The tax is 10.25%. So I'm going to do 100% plus 10.25%. And then that becomes the multiplier. So then I can use that number turned into a decimal as a multiplier directly on whatever I'm trying to do. So as an example, if $71.99 is the price of the shoes, price of shoes with discount, then I can use the multiplier. So 110, use my calculator here, 100% plus 10.25% is 110.25. 110.25% is this decimal. So this is my multiplier. Left out the 10, that's kind of important. And so now I'm just going to use that multiplier directly on 71.99. So the final price is 79.37. And this is the final price of the shoes with discount and tax. But wait, you might be wondering, does it matter if I apply the discount second and the tax first? It's a good question. And I'd have to kind of do more math to figure out whether I get the same answer. But let me answer that question more generally using the multiplier approach. And I think the multiplier approach has some advantages here that will help us see why the answer is generally no, it does not matter. So let's say we have an increase of 20%, but we also have a decrease of 12%. So let's do the multiplier process. For the first one, start with 100%, we add 20, then we take that and we say, hey, this is a percentage, so it turns into 1.2 is my decimal. So 1.2 is the multiplier for an increase of 20%. If I want to take something and increase it by 20%, I just multiply by 1.2. All right, decrease. 100% equals 100 minus 12 All right. So, and then this is 88%. All right. So this is my multiplier for a decrease of 12%. All right. So the great thing is that I have a multiplier for my increase, I have a multiplier for my decrease. So let's say I start with 200. 200 times 1.2, and then take that number and multiply it by 0.88. So this is increase, then decrease. Now let's do it the other way. Decrease 200 times 0.88, and then take that number and multiply by 1.2 for our increase. Oh, same answer. Decrease, then increase. Now, I could also just do it all together. It's a multiplier. 200 times 1.2 times 0.88. And in writing it like this, maybe I can see why it doesn't matter. I'm going to take off the equal signs just so we can leave it there. 200 times 1.2 times 0.88. So logically, what is a mathematical argument for saying the order doesn't matter? If we increase first or decrease and then increase. When we look at it like this, you should be able to come up with a compelling mathematical argument that sort of justifies, in general, it doesn't matter if we have an increase and a decrease or two increases or two decreases. The order we apply them in does not make a difference. I'm going to leave that to you to think about, and we'll kind of circle back to that when we see each other first. So, it doesn't matter. This is, and to answer the question, do I have enough money? Yes, my 420s should be enough money to buy the shoes. Thank goodness for the discount. Okay. So I think, as I said, I think that's enough sort of content to give you a fighting chance to do the percent worksheet. And I'm not saying that you're not going to have questions. I'm here for those questions. And that worksheet is not due for a week. Normally the in-class stuff is due the same day, but because we're actually meeting today, you've got a grace period to kind of dig into that. I want to go back to this first sheet because I want to talk about an application of percentages that I think is interesting, and maybe you will by the time you get there. And also allow me a chance to talk about cell references in terms of doing calculations. So as you can tell here, there is a little bit of a formula to convert odds into probability. I take 1 divided by 1 plus the odds, and then that gives me the probability as a decimal. And notice that I did not write 10.21 here. If I had, I would have got the same result. 1 divided by, I need parentheses here because I want to add before I divide, which is generally out of the order of operations. But this number and this number are the same. I'm getting more decimals here, so it looks bigger. Let me just shrink up the decimals here, so we can see that they match. Whoa. All right. And then this also changed here. I'm gonna make a comment about that in a second, but let's just go with number. Okay. So this is the same number. That's my point. What I did was I used a cell reference. And the reason this is awesome is because it allows me to do a lot of computations quickly. So how does it work? So C3, remember we said that the name of a specific cell is designated by its column and its row. So C3 is this number 10.21. So I'm basically telling Excel to take 1 and divide it by the sum of 1 plus whatever's in C3, which is this number. And it gives me the exact same answer there. Now, that's important that I write it like that, because if I use a special tool called autofill, shoot, goodness, I can, if I use autofill when I wrote the numbers out as they were, and then I say, hey, do that again, it's like, okay, I'll do the exact same formula over and over again. Helpful. But if I do it this way, Excel is clever enough to say, oh, you want to take the cell next to where I am and do this computation. And so it does all of these computations very quickly. If I was doing this in a calculator and writing down the answers, that would have taken me, I don't know, 10 minutes or something. And I would have had a probability of typing in something wrong, getting, changing the formula, making a mistake, writing the number down. There's so many places where errors would have come up. This is where Excel really starts to shine as a powerful tool. All right, so these are the probabilities as percentages. As decimals. So there's a mathematical way that we can kind of summarize the total kind of expected outcome, which is that 8.9%, about 9% of the time. I'm going to take these numbers, just the first couple of ones. I'm going to take these numbers and put them over here. I'm going to change them into, whoa, that's not what I wanted to do. Let's paste special values. Okay, I'm going to turn them into percentages so we can kind of have a conversation. So there's almost a 9% chance that when I buy a ticket, I'm going to get a $5 prize. It's really not that good of odds, but it's the best chance that I've got. There's a slightly lower chance, an 8% chance of getting a $10 prize. Great. So almost a 17% chance that I'm going to get a $5 or $10 prize. From there, the odds, the probabilities start to decrease pretty dramatically. You would probably not agree to like a 1% chance being a really good chance of something happening. When you see, I think it's really interesting now that in game casts of sporting events, they will show the probability that they think that team A or B is going to win. When the team's getting to 99%, right, it's like, okay, well, they're pretty sure they're going to win, right? Doesn't always happen, but pretty sure that that's going to be the outcome. So these things are pretty unlikely to happen, right? But they do happen 1% of the time, 1.6% of the time, 1.4% of the time. So basically, mathematically, what I can do is I can multiply the value times the probability of it happening, and that gives me an amount of money. These are money figures here. And then I can add up all of that, and I can figure out what is the expected value of a single ticket. And of course, this number is, a combination of all of the tickets at once. And so there's no prize value of this amount, but it does show us something important, which is it worth playing the game? I think you know what the answer to the question is, because people would not be selling lottery tickets if they were giving away more prizes than they were bringing in from selling the tickets. And this number can tell us how close that is. So the answer is $3.35. So basically, every time you play, you have an expected outcome of $3.35, which means you're losing $1.65 because the ticket was $5 to buy. That makes sense because the lottery company is going to win in the end and earn money from all of the tickets that it sells. Yes, it's going to sell a $75,000 ticket, which is going to feel great to the person who bought it because they only spent $5 to get the ticket. It doesn't happen very much. One of the things that you will run into as you do this course, and you've got to be aware of, is scientific notation. So I had to change these into number form, but they originally started off as scientific notation form. And that was because this number was so small that it was like, I'm just going to give it to you in this format. So something to be aware of. I don't know how, we'll kind of be on the lookout for situations where it arises. Here it's arising because this is the odds. It's a really big number, and I'm doing 1 divided by 1 plus that number. So it's going to be 1 divided by a huge number, which makes a very small number. And that's where the scientific notation comes in. There's really no difference from Excel's perspective in terms of like this number representation or scientific notation. Doesn't matter. Still use it, multiply. Notice that I did the same thing here with my cell references. I multiplied, but I didn't write the numbers directly. I used cell reference from B3 and D3. And then as I went down, I just had to do autofill and it did all of this for me. So I didn't have to type these formulas. All I did was say, dang it, I keep hitting that button. All I had to do was say, hey, I'm going to take this and I'm going to autofill. I'm going to teach you more about how to do that. And then at the end, I didn't have to add these numbers up myself. I just said, hey, Excel, can you add the numbers sum E3 to E17? E3 is this number. E17 is this number. This is kind of like computer programming a little bit. I mean, it actually is computer programming. It's very simple computer programming, but it's you're going to learn how to write some formulas in Excel and use things like mean, median, range, standard deviation, and it will do a bunch of computations for you, which is awesome because if you take something like standard deviation, it's a really annoying formula to do by hand. So it's great to have Excel be able to do that. Okay, we talked about a lot here. This is a pretty long video. You know, I probably should have said at the beginning, if you need to take breaks and pause and do stuff, you know, do that. I think you should have Excel running by the time you do this. I do think that taking notes can be helpful here in terms of writing down some big ideas. But you may find that you want to just take notes in Excel and have like books be, okay, this is week 1 notes and practice work. And so then you're kind of doing your own computations on your own. Maybe you're following along with what I'm doing and writing things out. But you just want to make sure that you're getting a lot of practice with Excel and feeling good about that. We'll talk more about that when we actually see each other on the 22nd. All right, y'all. Work hard. You can text me if you have questions. That's really the best way to get a hold of me. 765-335-5867. Oh, 6857. What? Now I'm questioning my sanity. Hold on, let's go look at the syllabus. Oh, hey. That's my Google Voice number, so that's why you're thinking, why doesn't this person know their phone number? Yeah, 5867. There's actually a story behind that number, but I'll save that for another time. If you have a question, send me a text. Let me know what's going on. We can meet up Tuesday, Thursday, Friday. Wednesday's a very busy day with other class and lab, but and I am going to have a form for you to fill out here about preferred office hours because I have all my office hours right now are TBD. But yeah, we can meet up and Zoom and do some virtual work. That's a really important way for you to get help and connect with me and kind of know more about my teaching philosophy. Very important that you understand, and I don't know if you picked it up from watching the video, but there's a lot of ways to do things. If something that I said doesn't make sense, I can give another way to do it. And you're going to have a math specialist and other people you can talk to about how to do math, colleagues. So there's not one right way to do things. I think that there are some better ways to do things and some worse ways to do things, but ultimately what makes sense to you, what you connect with, that's important too. All right, be good, work hard. See ya.